Hi gents, welcome back. We're going to have a look today at a little bit of revision. Since we have our topics nailed down, I thought that we would have a little go here at projectiles just to remind you a little bit about it. What did I want to say about projectiles? Well, just when I was picking out this question, I went for literally the oldest thing that I could find on examinations.ie. For some reason, Better Examinations isn't working at the moment for me. I'm sure it is elsewhere. And this, therefore, is the 2001 Applied Maths Leaving Cert. So just remember, when I ask you projectiles, I'm only going to ask you the A part of the projectiles question. Okay, so that is projectiles on a horizontal plane. So what we have here, we have a player hits a ball with an initial speed of u meters per second from a height of 1 at an angle of 45 degrees to the horizontal ground. A member of the opposing team 21 meters away catches the ball at a height of 2 meters above the ground. Find the value of u. Okay, so if you look at the diagram that they've given us here, I'm just going to make a little proposal. Let's forget the fact that the player is 1 meter tall and have this here as our starting point. Okay. And what we'll find is basically we're kicking it off the ground at a 45-degree angle to begin with. It's going to trace out all the way across there, and it's going to land in the person's hand such that it is 1 meter up. Okay, so we've moved, obviously it was 2 to go from there to there, but we've moved everything up a meter. I think it's just easier. It's still 21 here, so I don't see any reason why we shouldn't do that. It's just an easier way to think about it. Okay, things that you may have forgotten that I don't think are in the tables book is that, do I want to bring it down? Maybe not. Okay, let's go. It's that Vx is equal to Ux and that Vy is equal to Uy minus Gt. And we also have our Sx's, it's Ux by T, and Sy is Uy by T minus a half Gt squared. Okay, just the initial one here, it's U sine theta plus i's plus U cos theta j. Now when it comes to sine theta here, sine theta is sine of 45. You should actually know this off by heart. Sine of 45 is 1 over root 2, as is the cos of 45. Okay, so our initial velocity that we've been kicked with is u times 1 over root 2. So that's u over root 2 I plus u over root 2 j. Okay. So we can actually fill this in here pretty quickly. We can say that Vx is equal to Ux, so our initial x velocity, we just said that's u over root 2. Vy is equal to the initial y velocity, that's u over root 2 also, minus gt. We have that Sx is equal to u over root 2 t, and Sy is equal to u over root 2 t minus a half gt squared. Okay, hopefully you remember that. I know it's been a while, but obviously you're gonna have to do revision for it for the real thing. What I want you to do now is I want you to try and write out what are the 2 conditions that we're told when the ball is caught. What are the 2 things that obviously when the ball is caught, 2 things are going to happen. So pause the video or just try to preempt in the sort of 2 or 3 seconds that I waste here for you to say what are the 2 conditions. When the ball is caught, what can we say? We're going to say that the ball has, first of all, that Sx, okay, that's Sx, that's how far over it has gone. On the x-axis, it will have gone 21 meters, and Sy, the ball's height, will be 1 meter. Okay, that's assuming that the initial, I've taken the initial point to be here on our x-axis, and there's no reason not to do that. So when Sx is 21, Sy will be 1. That part we're sure that the t value will be the same in both cases. The time when it has traveled 21 meters is also along the x-axis is the time when it will be 1 meter high. Okay, so let's look at what the consequences of that are. So we can say that 21 is equal to sx, and sx is u over root 2 by t, and sy is equal to 1. So we can say that u over root 2t minus a half gt squared is equal to 1. And it's just simultaneous equations here. So you remember what the plan is. What do you get? I mean, it looks like simultaneous equations, but lots of variables. There's only u and t, and we're trying to get what is u. Okay, so the way to do it is to get t on its own. 21 root 2 is equal to u times t. I've multiplied both sides by root 2 there. And t is therefore 21 root 2's over u. And the reason to get t on its own is that we can now, into the more difficult one, the one that's got t squared, we can now replace t with 21 root 2 over u. Okay, so the equation will then only have u's in it and numbers. Okay, g is obviously just a number. So we get u root 2 times t. Now t is 21 over u, 21 root 2 over u. Okay, and the nice part about that is u divides into u and root 2 divides into root 2. So already we're onto a winner there, minus a half gt squared. Okay, give myself a bit more space. T is 21 root 2 over u, and it's t squared equals 1. So remember we said here, u divides into u, root 2 divides into root 2, we're left with 21 there, which is nice and handy. Then we have minus a half of g times, okay, let's square this. So you can square the top and square the bottom. When you square the top, 21 squared is 441. Yeah, and you root 2 squared is 2, so 441 by 2, 441, so 882 over u squared. Okay, and actually I see that it's a half of it, which is quite nice. So 21 minus, okay, so basically if you wanted to write a half g, you could write it as g over 2. So 2 divides into 881. So we get, yeah, we're back down to 441 after all of that. G, okay, they're multiplying, over u squared, and it's equal to 1. You can multiply everything by u squared, but you know what, first off, you can take 21 away from both sides. G over u squared is equal to minus 20. Multiply both sides by minus 1. 441g over u squared is equal to 20. So it follows, I'll do it up to the right here, 441g is equal to 20 u squared. Remember, we're just trying to get what u is. So u squared is 441g divided by 20, and u is equal to the square root of 441g over 20. We took g to be 9.8, I think, so let me just grab a calculator here. I'll type this in. 441 times 9.8 over 20, the whole thing rooted. It would obviously be plus or minus that, but u can't be a negative number. In this case, oh, and it's a nice number. It is 147 over 10 is equal to u. Or you can call it 14.7, obviously, if you wanted to. U is meters per second, I think. So that's what we get. So that's a handy enough question. Things were obviously very easy back in 2001. But it's a good one, I think, to do a nice little bit of revision on. Okay, so it's just a little recap. It's starting off with finding out what is the initial x value and y value. Okay, when it's starting off, it's knowing these things here. Okay, subbing them in, and then getting your initial conditions. Okay, not initial conditions, but your conditions when the ball is being caught. So the conditions that are given to you in the question, that at the same time as it's traveled 21 along the x-axis, it will have gone up 1 on the y-axis. Okay, gents, hopefully you found that useful. Any questions, please send them on. I'll be happy to do them out for you. Some of you have asked that I include uniform acceleration on the test, and some of you don't want that. So I'll happily I'll put it on the test, and if you want to do it, do it. And if you don't want to do it, don't do it. Okay, I think that's I think I'm being overly generous there, but with you. But anyway, I'm sure it's tough times, so we won't make things difficult if we don't have to. So yeah, keep up the revision, and I will do one. I'll do a separate video actually. Sure, we may as well do the pulley question. So I will do one because that's coming up as well. But that's for another time. Okay, gents, hope you're keeping well. All the best.